Okay, example 2. And sorry, this is linear regression. I think I had the titles wrong in the last two videos. So researchers monitor the number of wolves and rabbits in the wildlife reserve. If you think about it, what do wolves eat? Well, they eat rabbits, right? So they assume that the wolf population depends on the rabbit population. So if there's not enough food, aka rabbits, then the wolves will die off and vice versa, right? If there's too many wolves, then like the rabbits die off. Okay, so since wolves prey on rabbits, the researchers have collected the data below over the years. So I'll flip to the next slide and show you. But basically, let's determine the line of best fit and then the correlation coefficient. And we'll do both of those by hand and then also on Excel. And then we're going to graph the data and line of best fit. Does the graph support these theories? Okay, so here is the information. So let's actually fill in this chart. So we're going to add all of the rabbit population, which is going to be X. So 61, 72, 78, 76, 65, 54, 39, 43. I get 488. Okay, and let's add 26, 33, 42, 49, 37, 30, 24, 19. I get 260. Okay, and then X times Y is going to be that 61 times 26. Okay, so 61 times 26, and I get 1586. And this is going to be the 72 times the 33, right? The X times the Y. And I'm going to get 2376. And I'm going to do that all the way down. Now also, because we're finding the correlation coefficient as well, we're going to do X squared, which is going to be 61 squared, which I get 3721. And we're going to do the Y squareds, which is right here, 26. So 26 squared, and I get 676. So what I'm going to do is I'm going to fill all of these in and pause the tape. Okay, double check the numbers that you guys got, and then we're going to add these up. So 1586, 2376, 3276, 3724, 2368, 1620, 936, 817, and we're going to get 16. I put a comma, 703. I'm going to go ahead and do that for the other two. Okay, and that's what I got. So, and always, you know what, I always check these numbers pretty much with, I always correlate them with the numbers from the Excel spreadsheet. So if we want to actually even just go to the Excel spreadsheet right now, okay, I would like total these, make sure that they add 48, total these 260. I got 48 and 260. And then I would actually just graph these because these questions are so long sometimes. I always like to know whether or not I'm getting it right. So even though I will require you to show all your work, this is a really good indication of whether or not you're getting it right. So rabbit, let's go rabbit versus wolf population, and then we'll just say rabbit population, and then up the side, wolf population. Here we go. And we have the slope, the y-intercept, and then we can always go this r equals, and then we're going to go equals square root. And we put 0.7486 in there to see the correlation. So this is such a good tool to use right at the beginning of your question. This took me all of maybe 1 or 2 minutes, and then at least we know if we're on the right track. So let's see if we get the right answers for first the line of best fit. So let's go A equals number of data points. 1, 2, 3, 4, 5, 6, 7, 8. We have 8. Okay, the sum of the x, y's is 16,703. 16,703. minus the sum of the x's, which is 48, times the sum of the y's, which is 260. Okay, and that's all over the number of data points, the sum of the x squareds, which is 31,276, minus the sum of the x's, which we already know is 488, and then we'll square that. Okay, for the numerator, 16,703 minus 48 times 260. For the numerator, I get 6,744. And then for the denominator, I get 12,064. And I'm always so nervous to see if I got this right. I get 0.5. Let's round out. It's 559. Let's round up to 0.56. Okay, so it's pretty accurate right here, 0.5836. I'm okay with that. Okay, it may be rounding errors. So I'm going to continue, and I'm going to go. So we know we're going to sit at y equals 0.56x plus, and then now let's solve for b. So our b is going to be y bar, which is 260 divided by, how many data points? 8 again. And then minus 0.56 times x bar. So the average of the x's add up to 488. There are 8 data points. And now let's just put that in our calculator. 260 divided by 8 minus 0.56 times 48 divided by 8. I get negative 1.66. Okay, so let's call negative 1.66. Okay, and that's in there. And then I'm going to double check, what did Excel get? Excel, negative 3.0986. So I'm going to double check that. So I quickly recalculated everything. This number should be 2368, 65, 2405. And sometimes you're going to have to go through this, and it's going to be terrible. Okay, so 2368 minus 2405, that's a difference of 37. So I'm just going to add on 37 to this number. So this should be 740. And if that doesn't make a huge difference, then we're just going to leave our answer as it is. So this changes to 7040. Okay, so that changes to 7040. And then when we actually divide, we actually do get that 0.58. And then there's, of course, like rounding as well with that. So 0.58. So that's the only thing that we actually really have to change here. So let's just do 260 divided by 8 minus 0.58 times 48 divided by 8. Oh, that really changes this answer. I get negative 2.88. All right, 2.88, and that looks a little bit better. That's much more accurate. So we have that 5.8 there, 2.88, and that's how much. I don't even mind making mistakes on this sometimes, because that's how much that little 37-point difference is going to actually make. And it was the difference between me punching in 65 versus 64. So, sorry, I'm going to look at this. So now it pretty much is aligned. The y-intercept's a little bit off, but that's due to rounding error.